Welcome to this online revision session for AQA FP2. We will be looking at the June 2011 question 7 on De Moivre's theorem. As you can see, this question has 3 parts which we'll work through. Well, A part 1 looks like something that hopefully you've done in your previous work in preparation for this exam, very much textbook orientated. So let's start with that part. Okay, and it says that using De Moivre's theorem, show that cos 5 theta equals this particular expression, and then we've got to find a similar one for sine 5 theta. Well, what do we know? Well, De Moivre's theorem said something like this, didn't it? That if you take cos theta plus I sine theta, take it to the power of 5, it will be equal to cos 5 theta plus I sine 5 theta. Remember, this was something to do with the fact that cos theta plus I sine theta is a point on a unit circle, and so when you take a power of that point, it remains on the unit circle with the angle increasing by the power in terms of being multiplied by that power. Okay, so if we now expand this left hand side using Pascal's triangle, the binomial expansion, we know the fifth row of Pascal's triangle hopefully is 1, 5, 10, 10, 5, 1. Okay, you can always write the triangle out if you need to. And so if we write it out bit by bit, we're going to get cos to the power of 5 theta, just one of them, plus 5 lots, reduce the cos power by 1, increase the sine power by 1, so this becomes sine to the power of 1, or just sine theta. The next term is then 10, so Pascal's triangle. And the cos term will decrease its power by 1, and the sine will increase by 1, and so it continues. So we get plus 10 cos squared sine cubed, and then we get 5 cos theta sine to the 4th, and then we end up with sine to the power of 5. Now the only thing we've got to worry about now are the i's, because on the sine we've got an I. So in this one, we're going to get an I in here. The next one was an I squared when we squared it for the I sine theta. So this will then become a negative sign because it becomes minus 1. This one is I cubed, so this will become a negative I times this one. And the next one has got I to the 4th, which is plus 1, so that's okay. And the last one is I to the 5th, which is the same as minus I. Okay, and that will equal the cos 5 theta I sine 5 theta that we had before. So to pull out the cos 5 theta from this, the cos 5 theta is real, so we collect the real terms together. So we can see the real term here is the cos 5 theta, the minus 10 cos cubed sine theta, and the 5 cos sine to the 4th theta. So if we write that down, we're going to get the fact, equating the coefficients, that cos 5 theta, the real parts rather, is going to be equal to cos to the power of 5 minus 10 cos cubed sine squared, and then we got plus 5 cos theta sine to the 4th, and similarly to get sine 5 theta we're taking the imaginary parts. So what have we got? Well, we got this one, which is 5 cos to the 4th sine theta, and then we got minus 10 cos squared sine cubed theta, and then finally at the end we got a minus sine to the power of 5 theta. Looking at that, that's not right. And why not? Because again, you just always got to be careful with your negative signs. Remember, the I to the power of 5 is not negative, it's positive, isn't it? Because I to the 4th is 1, so I to the 5th is I, so that makes that a positive sine to the power of 5. Okay, so we got our statement in for sine to the power sine 5 theta in part 1. Now we've got to deduce the tan 5 theta. Well, we know that tan 5 theta is going to be sine 5 theta over cos 5 theta, and so that must be these two terms, one divided by the other, so we know it's going to be 5 cos to the 4, I'm just going to put C4, shorten this, sine minus 10 cos squared sine cubed plus sine to the 5 all over cos to the 5 minus 10 cos cubed sine squared plus 5 cos sine to the 4. Well, somehow we've now got to simplify this and obtain tan theta out of this. So if divide everything by, what should we suggest? Cos to the power of 5 all the way through. So if we divide by cos to the 5, we can see that in that first line, I'll just get a straight line on here. So this is going to give us, well, 5 cos to the 4th sine divided by cos to the 5 will give us 5, and you're left with sine over cos, which is tan, minus 10, and this time we're going to get the cos's disappearing to give us sine cubed over cos cubed, which again is going to give us tan cubed, and then we're going to get tan to the power of 5 because of the sine to the 5 over cos to the 5, And on the bottom we're going to get tan 1, because the cos cubed, sorry, cos to the 5th divided by cos to the 5th here. And then it's going to be minus 10, and it's going to be sine squared over cos squared left when we divide through, which gives us 10 tan squared. And then we're going to get plus 5, and again the cos will disappear and leave us with sine to the 4th over cos to the 4th, which is also tan to the 4. And then you can see we're home and dry. Yep, because on top we can take out a factor of tan. So we'll get tan theta, and we're left with 5 minus 10 tan squared, sorry, cubed theta, plus tan, sorry I was right in the first place, it is tan squared because we've taken a factor of tan out of there, and then we've got tan to the 4, so we've taken a factor of theta out of tan theta out of there, and on the bottom we've still got the 1 minus 10 tan squared theta plus 5 tan to the 4. Okay, well, let's have a look, see where we get the marks in all of this. Your opening statement here will give you a method mark in part 1 of this question. And then expanding it into some form here will give you, assuming you do that correctly, will give you a mark. Realizing that you've got to equate the real and imaginary parts gives you a method mark there. Obtaining the correct answer for the cos 5 theta gives you 1 accuracy mark, and similarly the sine 5 theta will give you an accuracy mark of 1 mark. Into part 2, realizing that tan is sine over cos, give you a mark. Then your method of substituting in the two parts and then cancelling or simplifying it by dividing through by cos to the power of 5. That gives you a method mark there, and then obtaining the correct answer gives you an accuracy mark at the end. Okay, now we're into part B of the question. And the first part says explain why tan pi by 5 is a root of this equation. Well, you can see at the top right side here, tan 5 theta is equal to this expression. Well, what do we know about tan pi by 5? Well, if we substitute the angle theta equals pi by 5 into this expression, we get tan of 5 lots of pi by 5, which is going to be the tan of pi, which is 0. So we're saying that the right hand side of this equation is equal to 0. Well, there's two ways that could happen. Either the tan theta is equal to 0, which would mean theta is 0, or the expression here in the brackets must therefore be 0. So we've substituted in the pi by 5 as the angle, so the part that's 0 must be that piece in the right hand side, so the 5 minus 10 tan squared of pi by 5 plus tan to the power of 4 of pi by 5, that must equal 0. So that's from the right hand side of this expression. Okay, and then it asks you for the other three roots of this. Well, for the tan, to find the roots, we know the tan of 5 theta must equal 0 to form an appropriate equation. So what does that tell you about 5 theta? Well, that tells you that 5 theta must be a multiple of pi, because all the multiples of pi, when you take the tan of those values, it equals 0. So that is telling you that theta therefore must equal k pi over 5. So there is an infinite set for k, where k can be any positive or negative integer. So if that's the case, what values of k can we take? Well, we could take k as 1, 2, 3 and 4, or we could take k as negative 2, negative 1, 1 and 2. Notice I cannot take 0 because 0 would give you theta as 0, and that corresponds to this factor tan theta being 0. So the 4 values we could take, as we said, there are 2 sets we could consider, and if we want theta to be between, let's say, minus pi by 2 and plus pi by 2, sorry, minus pi and plus pi, then k could take the values minus 2, minus 1, 1 and 2 as being the possible solutions. Okay, and we could therefore write down the other 3 solutions that we want as being tan theta as being the tan of minus 2 pi over 5, tan of minus pi over 5, and tan of 2 pi over 5. Okay, so there we've obtained our alternative roots to this equation here. Okay, 3 marks for that part. Well, obviously for explaining where this value of 0 comes from, that tan 5 theta is 0 because of the substituting theta as pi by 5, and therefore must be a solution. That's 1 mark. For then explaining how it fits that equation is the 2nd mark, and then for obtaining these alternative values you get a mark for doing that. Okay, alright, well, into part C of this question it says deduce. So this means it follows on from. Sorry, when I prepared this I put k as 2, 3 and 4. Actually I've just used, in this case I've used minus 2, minus 1, 1 and 2, haven't I? Not those values. Okay, so we know then that these 4 possible values for tan theta, in other words for t, in this quartic equation, these are the 4 roots. So what do we know? Well, we can see here these 2 parts are multiplied together. Now what is it in a quartic that's multiplied? Well, it's the product of the roots, and the product of the roots for a quartic will be equal to E over A, where A is the coefficient of t to the 4th, B is the coefficient of t cubed, C is the coefficient of t squared, d is the coefficient of t, and e is the constant. So we know that the product of the roots is equal to 5 in this case. That's the e over a value. So what are the roots? Well, they were these things, weren't they? So this is the fact then that tan of minus 2 pi over 5 multiplied by the tan of minus pi over 5 multiplied by the tan of pi over 5 multiplied by the tan of 2 pi over 5 must therefore equal 5. Okay, well, what do we know about tan? Well, the tan function, we know that if you take tan of theta, it equals the negative of the tangent of minus theta. Yeah, because of the symmetry of the graph. So in fact, the tan of minus pi by 5 is minus the tan of pi by 5. And similarly, the tan of minus 2 pi by 5 is minus the tan of 2 pi by 5. So they both create a negative and a negative, which multiply together to give you a positive. So in other words, this simplifies down to the tan squared of pi by 5 times the tan squared of 2 pi by 5 equals 5. Take the square root on both sides, that gives us tan of pi by 5 multiplied by the tan of 2 pi by 5 must equal either the positive or the negative root of 5. But we know that the tan of pi by 5 and 2 pi by 5 are both positive. Yeah, but these particular values of theta, tan of pi by 5 and tan of 2 pi by 5 are greater than 0. So in fact, what we must have therefore is just the tan of pi by 5 multiplied by the tan of 2 pi by 5 must therefore just be equal to the positive root. Couldn't possibly be negative. There we go. Right, well, where do we get the marks? Well, for realising that the product of the roots is 5 is our starting point. For a statement related to these tangents, the fact that the tan of the angle is one is the negative of the other, I'll give you a mark. An accuracy mark for coming up with this statement here correctly. And for square rooting it and ending up with the positive answer, you get a mark. And for explaining why you have ditched the negative value of root 5, we'll give you an explanation mark there. You need to explain or show that you've understood why we got rid of that negative sign, and that needs to be explained. Well, hopefully you found that solution helpful. For further support, please go to the Further Maths Support Programme website.